Namaskar Mitro. Good morning, dear friends. Hope you all are good, doing well, keeping yourself safe, and enjoying all these learning videos. In the last lecture, we discussed about the image formation through convex lens, different cases of image formation. In this lecture, I will tell you about the image formation by concave lens, the magnification produced by the lenses, and lens formula which is used for numericals. I hope you are watching all the videos continuously, and I request you to watch so that you can learn the things at your own way, and that will become fruitful for you. So let us begin with this new video lecture.
So let us begin with the new lecture. In the last video, we discussed about the image formation by convex lens. In this lecture, we will talk about the image formation by concave lens, and at the end, you would be able to compare how these two cases are different from each other. So let us see how this lens behaves in case the image formation is considered. In the first case, object at infinity, as we had taken the same case in case of convex lens. So this is the concave lens of this is principal axis, optical center, and this is distance equal to focal length and location of the focus. Then next is 2f. 2f is double of f. Let f is 2 centimeter, then 2f would be 4 centimeter. If f is 1.5 centimeter, 2f would be 3 centimeter from the optical center. So when the object is at infinity, then again we would consider few of the rays originated from the object. They will pass through the or appear to pass through the focus after being refracted. So image is formed at f on same side. Wherever the object is placed, on the same side image is formed. Its nature is virtual and erect. Why? Because the rays are not really intersecting. And the third one is about its size. This size is point size image. We can have all 6 cases here also, but we will not take them in detail, because for every location of the object, the image is always formed between f and o, and its nature is virtual erect, and the size is smaller than the size of object. So in general we can take object at any location beyond f. So in that case, in all those cases, the image will be formed between so you can take the object anywhere beyond f. Let I am taking the object between f and 2f. And this is AB object. The first ray is parallel to principal axis. This ray will pass through the this ray will pass through the focus after being refracted from the concave lens. The another ray we will take passing through the optical center O. So this ray, these two rays intersect here between F and O, and image is formed as A dash B dash. So what are the properties of image? The first is position. It is between F and O on same side. Nature is virtual and erect, and size is smaller than object. So in all cases where the object is at 2f, whether the object is beyond 2f, the image is always formed between f and o. Even though if object is placed between f and o, then also image is formed in the same way. So for every other location of the object, the image is always formed on the location between focus and optical center. Now, so we won't take in detail all the 6 cases here. For all the cases other than object at infinity, image is always formed between f and o, and the nature of image is virtual erect, and the size is always smaller than the object. So one more important term we have to understand here, that is magnification. Magnification is basically given by m is equal to size of image upon size of object, that is hi upon ho. Also m is equal to v upon u, and this is image distance upon object distance. Then we have lens formula. 1 upon f is equal to 1 upon v minus 1 upon u, where v is image distance, u is object distance, and f is focal length. Then we have sign conventions. To understand sign conventions, we just take a very simple technique to be followed. Let this is principal axis, and this location is optical center. So all the distances right to the optical center are positive, left to the optical center are negative. Moreover, above principal axis are positive and below principal axis are negative. So these sign conventions are very important whenever you are using either the formula of magnification or the lens formula. 1 upon f is equal to 1 upon v minus 1 upon u. So if we talk about object distance, since object is always placed on left side of the optical center, so in such cases the object distance is negative. If image is formed on right side, then image distance would be positive. If image is formed on left side, then image distance would be negative. If we are taking object above the principal axis, its size would be positive. If image is formed below the principal axis, its sign would be negative. So these are very important points to be remembered as far as the magnification and lens formula is concerned. And when we are solving numericals based on these two concepts, then you are you must be very careful about the sign conventions. So if m is positive, then nature of image is virtual and erect. If m comes negative, then nature of image is real and inverted. So these are the very important two very important concepts when we talk about the image formation by the two lenses and the numerical problems based on these two mathematical formula. I hope you understood these two concepts. If we summarize for the convex and concave lenses, then how do we use the sign conventions? For convex lens, focus lies on right side of the optical center, so focal length is positive. For concave lens, the principal focus lies on left side of the optical center, so focal length would be negative. Object you always place on left side, so u would be negative, and here also u would be negative. V, that is the position of image. This image is formed on right side in case of convex lens, so it would be positive, except image is formed on same side. Here V is always negative, in which case the image is formed on same side by the convex lens, that is object between F and O. In that case V would be positive. So you can verify by all the cases of image formation that if M is positive, then nature of image is virtually rect, and if M is negative, then nature of image is real and inverted. Thanks for watching this video lecture. In the next lecture we will discuss about the few more things, and the major concern is power of the lens. Thanks for watching. Keep watching.